So first, why we want to talk about database and SQL? Because we need data to do our magic. If you do quant, that's obvious. And then there are a lot of data in different formats at different locations. So getting data is not always easy. And data has its context, like what does it mean? And if you should use it, what's the data quality? A lot of things behind just data. And then we spent significant amount of time querying data, like collecting data, querying data, and cleaning data, transforming data. So let's start from some basic concept before we get to query. There are some important related concepts: data warehouse, data pipeline, and data modeling. So what is data warehouse? Basically, a data warehouse is a database. So it is some place that you store data. It's an organized collection of data. It's not just one set. This is an example. You have data collected from different sources, like customer support. If you call an organization, complain about something or ask about some question, those could go to a custom support system and all the ticket number and those type of information. And you could have marketing, like you receive all the email from companies. Those are marketing data. If you open the email, if you click the link in the email, all those actions usually will be tracked. And those data are stored in the email campaign database. You could have your user activity, like a user visit your website, user who logged in, interact with other users, and things like that. It can be somewhere else. And you could have API activity, like your company can provide API, and you could have your payment. If you own the payment, the system will be in-house. But if you outsource, use third party for process your payment, then that data is stored in the payment database. And then all of the data, you will get it together and put in one data warehouse. Those are separate. This type of data warehouse can support further data pipelines. When we talk about data warehouse, depending on the audience, if it's an engineer using that data warehouse, it will be very different from a data warehouse that's used by analysts and scientists. Usually data used by analysts and scientists, it's more structured. Why we want to use data warehouse, not just use those individual database, since data is already there? Because first, you probably want some rule around how long you want to keep the data. So if you want to get data from different sources, you could do that. But the problem is they could have different format. They could retain the data for different time frame. Maybe this database, you can only get like 6 months. That's 3 months, that's 2 years. So you have a centralized data warehouse, you can control how long the data you want to keep. And you can also, when data flow from the individual database to this big data warehouse, you can clean the data and transform the data to be more consistent, a central view of what you know about the customer. You can also augment the source. Think about, you have a customer call the support, and the support will be able to check this user's activity, know what the user did before. So those type of data augmentation, you can share data across different functions, require you to have a data warehouse. So then what is a data pipeline? Data pipeline basically is to move data from one warehouse to another warehouse. That's the pipeline. And there are a lot of movement around. So at a company, it's very unlikely you only have one copy. You have so many different copies of the same information. You can have the user activity saved in different database with different format. They could have the same information. And those data can be very messy when they get from original source data lake. Data lake is not the data warehouse ready for query. Basically, it's a dump of all the data there, not the database that's ready for query. So from data lake, usually engineer will work on the data from data lake and clean it and model it to data mart. Data mart is the one, if you go to work as an analyst or scientist, that's usually the one you will work with. Occasionally, you will work with some very end-heavy company that don't have this tool clearly separate. So you could query very messy data from here. That will cause a lot more difficulty. But then when you have a data mart, if you are analyst, you will build extra layer of more aggregate data. Like you could have user funnel from how many percentage of user coming in a certain week goes through impression to click the button to sign up to do something meaningful. You can have a user funnel data already pre-aggregate there. And then you could have the active number of users, the number stored somewhere there. You could have the monthly revenue data, and then those data will fit into data dashboard. So this is another layer. But usually this is already after you aggregate the data, after analysis. The difference between data lake and data mart is how structured the data is. Usually when the data gets to data mart, it goes through the data modeling. So let's look at the building blocks of relational model. So when you move from data lake to data mart, that's when you need data modeling. You will transform a messy pool of data to be this type of relational model. So this is an example, very baby example. If you look at, there's a fact table. Those are called dimension table. So the fact table has foreign key. So a foreign key is a key you use to join from one table to another table. For example, but if you look at location, you can see if you want to know the detail of the location, you can join it back to this location table using this primary key. So the primary key for the for a table is the unique key. So each primary key, each value will identify one record. So it's unique. There's no duplicate in this table. Why we need this foreign key to join to the location table? Why not just, you can basically put this information with this table, stack it up. Why not doing that? It's not efficient. Think about if it's only 1,000 lines, doesn't matter how you structure it, it's cheap. But if it's 1 billion, 2 billion records, think about how much duplicate information you will need to stack up, because this sales table has like one customer can buy different time, right? There's multiple customer ID, and one customer can buy, like one product can be bought by different customers. So that can duplicate. And you could sell many products from single location. So you'll have a lot of multiple records of this. If you just stack up all the information, and you will make this table very inefficient. That's why when you do the data modeling, you try to separate table to be that you cannot separate it anymore. So there are each entity basically is each table. So that's the same thing. When they say talk about entity, it's a table. The table usually is a business concept. Like this is about a customer. This is about a product. And then each entity, each concept has different attributes. So those are different attributes of the customer. And then the table has different relationship, right? So how you join the sales table to different table. So the real case will be way more complicated than that. The user have multiple accounts, and one account can have multiple user, and each account can have one primary user, some associate users. So it gets very messy when you handle real data. That's why when you start a project, you usually have to talk to PM, talk to your stakeholder about what data you actually want to use. Because depending on they are interested in account level, they're interested in specific customer, or they're interested in the primary user of that account. So that depends on what they want, you aggregate data differently. What are the difference between fact table and dimension table? So usually you can think of a fact table as a time series. So you have different events built up. A user can visit your website in multiple sessions, and it's a time series of behavior. The relation of the table is usually like one-to-one, one-to-many, or many-to-one, many-to-many. Fact table usually won't represent one-to-one. It could represent one-to-many. You could have customer, you can only match to one customer in the customer database. You can have many-to-many relationships. Like if one account can have multiple users, one user can be associated with multiple accounts. That's a many-to-many relationship. Usually fact table can map to different records. Dimensional table has a primary key, and it has like one record each row. It just describes that specific concept, like the customer. So each customer is one record. And those dimension table can be referenced by multiple fact table. In this case, you have sales as a fact. For each fact table, you can refer to the customer. The dimension table doesn't change as often, but the fact table change very frequently.